Hello everybody, welcome back. This is Jonathan Gardner covering Sergey Lang's Basic Mathematics, and this is section 11.5, which we're still in trigonometry. This is the addition formula for sine and cosine. And I've written on the side here some of the identities that we need to remember that we'll be using for proving this theorem. So theorem 3 states that for any angles A and B, sine of A plus B is equal to sine of A cosine of B plus cosine of A sine of B. Okay? And then cosine of A plus B equals cosine of A cosine of B minus sine of A sine of B. Okay, let's look at this formula really quick to make sure we understand it. So when we have sine of angles that are added together, we take the sine of the first angle, we multiply it by sine of the second angle, and then we add to that the cosine of the first angle times the sine of the second angle. Okay, so basically we're taking sine of and cosine of each angle, multiplying the sines and cosines with each other, switching the angles and then adding them together. Cosine of A plus B. So we take cosine of A and cosine of B, we multiply that together, and then we subtract from that sine of A and sine of B. Okay, this is what this formula does. Let's prove this. And in order to prove this, we'll prove the second formula first. And the way we're going to prove this is we're going to find the distance between 2 points that have been rotated through the angle A plus B. Okay, and this distance will relate. We're going to take the distance two ways in two different coordinate systems, and this will relate cosine of A plus B with cosine of A and cosine of B and sine of A and sine of B. Okay, so to start, for the first coordinate system, where I'm going to write 1 over here, we're going to choose the axis this way. We're going to start with the point P, which is equal to 1, 0. We're going to rotate that in angle A, and then we're going to rotate that in angle B. And we're going to end up with the point Q, such that the point Q is going to be, well, the x-coordinate will be cosine of A plus B, and the y-coordinate will be sine of A plus B. Okay? In the second coordinate system, we're going to start with the same points P and Q, except the coordinate system is going to line up with the angle A, and I kind of messed this up. So A, we're going to go minus A degrees to get to point P, and then we're going to go B to get to point Q. So we're going to take, so P is going to equal cosine of minus A, sine of minus A, which we can rewrite as cosine of A minus sine of A. So we're using this identity up here, that cosine of a negative angle is the same as cosine of the positive angle, and sine of a negative angle is minus sine of x. I should say minus, not negative. Now Q, however, is going to be, in this coordinate system, Q is going to be cosine of B sine of B. Okay? And so we're going to relate the distances. The distance between these 2 points won't change. The points haven't moved. The way we're measuring the points has moved. So we're going to measure the distance between these. So distance between point P and Q in coordinate system 1 squared. Okay? What's that's going to be? So that's going to be, we're going to take the difference between the x-axis, so cosine of A plus B minus 1, and square that. And then we're going to add the difference in the y-coordinates. What's the sine minus 0? So we're just going to take sine squared of A plus B. Okay? And then over here, the distance between P and Q in the second coordinate system squared is going to be the same thing. We're going to take cosine of B and subtract cosine of A, square that, and then we're going to take sine of B, and we're going to add, because we're subtracting a minus, so subtracting a negative, we're going to add sine of A and square that. Okay? That's what we're going to get. Okay, so let's do some algebra here. So I'm going to move the equal signs over here. So we're going to get cosine squared of a plus b. Then we have a cross term. We have two cross terms. Minus 2 cosine of a plus b. Then the minus 1 times itself squared, so that's just plus 1. And then we have plus sine squared. I need a sharper marquee. A sharper Sharpie. Okay, now we note that we have over here, we have sine squared of a plus b, and we have cosine squared of a plus b. So what does that mean? Cosine squared of a plus b, sine squared of a plus b. Well, sine squared of an angle plus cosine squared of the same angle is equal to 1. So we're going to replace those two with 1. Then we have the minus 2 cosine of a plus b. We have another 1 that's left over, so we get 2 minus 2 cosine of a plus b. On the other side, we are going to get, it's going to be a little bit more messy because we have cross terms here. So we have cosine squared of b minus 2 cosine b cosine a plus cosine squared of a. So we're expanding this sum here, this difference that's squared. We do the same thing for sine. So we get sine squared of b plus 2 cosine, sine of a, sine of b, sine of a. And then we have sine squared of a. Okay? And we can tell right away here that these two terms, again, we have cosine squared plus sine squared. And over here we have cosine squared plus sine squared of the same angles. And so we can replace both of those with 1. So we get 1 plus 1. So we have 2 minus 2 cosine A, cosine B. I'll just rewrite the order there. Plus 2 sine A, sine B. And these two are the distances that we've calculated using different coordinate systems. So they should be the same. Right? And so we can set these two things equal to each other. The distance between P and Q over here is the distance between P and Q. We didn't move the points, we just changed the way we measured them. And so we take them equal to each other. So we get 2 minus 2 cosine A plus B equals 2 minus 2 cosine A B cosine B plus 2 sine A sine B. So we can eliminate the 2's. We have a minus 2. We can divide everything by minus 2. So we get cosine of A plus B is equal to cosine of A, cosine of B. Remember, we divided both sides by minus 2 after subtracting 2 from both sides, minus sine A, sine B, because positive 2 divided by negative 2 is minus 1. So we have proven, let me scroll that up a little bit so you can see it better. We have proven that cosine of A plus B is cosine A, cosine B minus sine A, sine B. Okay. How do we go about proving the other one? Well, we start with the proof that we just had. So we say sine of A plus B is the same as cosine, of A plus B, and we have to subtract pi over 2. We're using this relationship here. The cosine of an angle minus pi over 2 is the same as sine of the same angle. These two things are really just the same. It's just using different x's. Okay? And so what this turns out to be, well, using the thing we just proven, we get cosine of A times cosine of B minus pi over 2. I just took this as the second thing that we're adding. And we're going to subtract sine of A times sine of B minus pi over 2. Okay. Well, what's cosine of B minus pi over 2? That's just sine of A. Sine of B. Okay. And then we have minus sine of A. And what I'm going to do here is I'm going to take sine of minus, and I have to flip the signs here, so it's going to be pi over 2. Let's do it this way. Minus B plus pi over 2. Okay? So I took a minus sign out, which turned the b negative and the pi over 2 positive. And so I'm just going to keep this over here. Minus sine of a times minus sine of b minus b plus pi over 2. Okay. Okay. And so that's minus times a minus is sine a times sine of minus b plus pi over 2. Okay. Well, when we're adding pi over 2 to an angle, so if we take sine and we add pi over 2, that's the same as cosine of that angle. So this is plus sine a times cosine of minus b. And cosine of minus b is just cosine of b. So we get sine of a cosine of b. So this is equal to cosine of a sine of b plus sine of a cosine of b. So sine of a plus b is equal to this. That was rather easy to prove. The trick here was converting this to a cosine by subtracting pi over 2 degrees, pi over 2 radians, sorry. Cosine of a cosine b of pi over 2, that's a sine of b. And then we suck out a minus sign to flip the sign. And then we have sine of minus b plus pi over 2, which is just cosine of minus b, which is just cosine of b. So that's the trick there. Okay. Now there's a corollary that if we have the difference of two angles, a minus b, that's going to be sine of a cosine of minus b, which is just cosine of b. And then we're going to subtract, or we're going to add cosine of a sine of minus b. So sine of minus b is going to be negative. So we're going to subtract cosine of a sine of b, because remember, sine of b is negative. Sine of minus b is the same as minus sine of b. And then on the other hand, we have cosine of a minus b. That's going to be cosine of a, and cosine of minus b is just b. And then now we have sines, and the sine of minus b is going to be positive, so we flip that negative to a positive. We're going to get sine of a sine of b. Okay, so when we're subtracting, we just flip the sign. That's basically all we have to do. All right, so there are a couple more identities using this formula that we're going to explore here. Before we do that, though, let's see how we can use this to calculate sine of something like pi over 12. We note that pi over 12 is the same as pi over 3 minus pi over 4. Okay, and we know the sine and cosine of this, and we know the sine and cosine of that. So let's rewrite this as sine of pi over 3 minus pi over 4, which we can rewrite as cosine, sine a cosine of pi over 4. And then we're going to subtract cosine of pi over 3 sine of pi over 4. Okay, so what's that going to equal? Well, sine of pi over 3, that's going to be root of 3 over 2. Cosine of pi over 2, pi over 4, that's root of 2 over 2. Minus cosine pi over 3, that's 1/2. And sine of pi over 4 is root of 2 over 2. Okay. Doing some algebraic manipulations, we note that we can pull out a common factor of root of 2 over 4, and we're going to get root of 3 minus 1. This we can rewrite. We multiply the top and the bottom by root of 2 over 2, root of 2 over root of 2. So it's going to be 2 over 4 root of 2, or this is just 1 over 2 root of 2. So we write that as 1 over 2 root of 2 times root of 3 minus 1. And that is sine of pi over 12. And we can use techniques like this to calculate pretty much any angle we want. We just have to be really smart about choosing the sums or the differences. Okay. Now what happens if we were to take sine of 2x? So we're taking the double angle. This is not sine squared, this is sine of 2x. Well, that would be sine of x cosine of x plus sine of x cosine of x. So we get 2 sine of x cosine of x. And cosine of 2x, well, that'd be cosine cosine minus sine sine. Well, cosine of the same angle multiplied by itself is cosine squared of x minus sine squared of x. Note that these aren't being added together. You can't use Pythagorean's theorem to turn it into 1. Okay? And then we can turn this formula around and we can calculate that cosine squared of x is going to be 1 plus cosine of 2x all over 2. Okay? I'm not going to tell you how to do this. It's not in the book. This is a fun little game for you to figure out how to solve this. And sine squared of x is going to be 1 minus cosine 2x all over 2. Okay? So in solving this, the first thing that my mind is drawn to is the sine squared of x term is disappearing, right? Well, how can we get rid of a sine squared of x term? Well, if we had sine squared of x and we add cosine squared of x, right? Then that would be equal to 1. Okay, so if we have to take, I'll just kind of sketch it out for you really quickly. So we have cosine squared of x minus sine squared of x plus cosine squared of x. But I just added a cosine squared of x, so I need to add another cosine squared of x to keep the universe balanced. And so this is going to be cosine squared of x minus 1 plus cosine squared of x, or 2 cosine squared of x. That's where the 2 in the denominator comes from, and that's where the 1 plus comes from. So that's kind of the trick to solve those. I kind of gave away the keys of the kingdom. All right, let's choose a different formula here. Suppose that x is a number such that sine of x equals 0.8. So we don't know what x is. We just know that sine of x equals 0.8. Okay, and we know that 0 is less than x is less than pi over 2. So x is in that first quadrant. So what would sine of 1.6, which is just sine squared of x, or sine of 2x, I'm sorry. This confuses even me, so we have to be careful. So note that if sine squared of x equals 0.8, cosine of x, what is that? Well, using the identity of Pythagorean's theorem, we can write cosine of x is the same as the square root of 1 minus sine squared of x. Okay, so that's going to be square root of 1 minus 0.8 squared is 0.64. So it's going to be the square root of 0.36. Well, the square root of 0.36 is in fact, I'm sorry, no square root. This is equal to 0.6. Okay? So cosine of x is equal to 0.6. So 0.8 squared plus 0.6 squared should give you 1. Okay? So sine of 1.6 is going to equal 2 times sine of x, which is 0.8, times cosine of x, which is 0.6. So it's going to get, let's see, that's 0.48 times 2, 0.96. Okay? So sine squared of x is 0. Sine of 2x, sine of the double angle, is 0.96. Let's take another example. In this example, we want to calculate cosine of pi over 8. Note that we already know what cosine of twice pi over 8 is. That's cosine of pi over 4, which is root of 2 over 2. Okay? So we're going to use this formula. Cosine squared of x is equal to 1 plus cosine of 2x, all divided by 2. Okay? We know that twice the angle, so if we take x as pi over 8, 2x is pi over 4. So we're going to get cosine squared of pi over 8 is equal to 1 plus cosine of pi over 4, which is root of 2 over 2, all over 2. So we take the square root of both sides. This is going to be the square root of 1 plus root of 2 over 2, all over 2. Or you can rewrite that as the square root of 1/2 plus root of 2 over 4. I think he uses 1 over 2 root of 2. He just multiplies the top and bottom by root of 2, and so he gets the square root of 1/2 plus 1 over 2 root of 2. Okay, that's cosine of pi over 8. If you wanted to calculate the actual value in decimal terms, you could, but this is good enough. This is something that's very useful. We will use that a lot, okay? We'll see things ending up like this a lot, and it'll be easier to do it for that way. All right, sine of pi over 8. Okay. So for sine of pi over 8, we're going to use the property that sine squared of x plus cosine squared of x is equal to 1. We know what cosine squared of x is. Cosine squared of pi over 8 is going to be 1 half plus 1 over 2 root of 2. And then we're calculating for sine. We want to calculate sine of pi over 8. So pi over 8. So we're going to take sine of pi over 8 is equal to the square root of 1 minus 1 half minus 1 over 2 root of 2, or it's the square root of 1 half minus 1 over 2 root of 2, which is very pleasant because it is very similar to cosine of pi over 8. It's just a minus sign instead of a plus sign. That's why we leave those things in this form, because it's easier to look at and sometimes easier to remember. That is all the examples they have in this section. There is a lot of different exercises here to calculate cosine and sine precisely of certain angles that you typically just plug into a calculator. I won't try to spoil a lot of fun. There's a couple of proofs here as well, so that will be fun. Anyway, there's not much else to report here. I hope you enjoyed this section. I hope you enjoyed this section. Guys, have a great day. Take care and bye-bye. Thank you for watching this video on Sergey Lang's Basic Mathematics. You can find the series on the left, and on the right you can click to support my channel. Thank you very much. Bye-bye.